It's wonderful to be back in Scottsdale and wonderful to see so many friendly faces and so many new friendly faces this year. My job right now is just to introduce my partner, Brad Holtz, who's going to give an updated view of the CAD, CAE, BIM market based on some research that Cyon Research did this year. And with that, let me hand the microphone over to Brad.
What I'm going to do today is to blast through, in about 20 minutes, presentation materials that many of you have seen me give before. But it lays the foundation for viewing the last half, which is, first, some new views on how we think about the market, some data that Cyon Research and Merrill Lynch did. We collected together and published a report in January. And then later on, we have a work in progress. This is a follow-on to the survey that we published in January. We're doing this work on our own with the assistance of Jay Vlieshauer. We have 500 responses already, and preliminary look at the data is very, very interesting, and we'll give you a sneak preview of that. So with that, let's begin. I'd also like to thank our sponsors, our major sponsors. Autodesk will be sponsoring the Friday night gathering at La Puesta, and Spatial is our lunch sponsor. Here we go. So we try to look at the big picture, try to get a handle on things that are very vague notions and make sense of that. And in order to do that, we look and break things down into individual vectors and then try to make those vectors understandable and combine them in ways that are insightful. So we, as a people, crave stability. And unfortunately, as we've seen with earthquakes, with global warming or cooling, depending on who you believe, the Earth is not a steady state system. And change is something that happens to us, but not only does it happen to us, it's also necessary for life to go on. And the big problem that we have, we've always lived with different types of change, but what's happening now is that the rate of change is accelerating, and the accelerating rate of change is called jerk. And what's different today is that the changes that we're seeing are happening within lifetimes rather than across generations, and we're seeing major global changes. And systems and people can accept small changes bigger than big changes. If you piss in the ocean, so to speak, nobody's going to really notice. But if everybody does, over time, it accumulates, and the system can no longer absorb the perturbations so that the systems are affected at a global scale. So we basically have the tendency to take something and run it well beyond the capacity of the system to absorb those small changes. And that's really what we're running into today as overall. Also, another thing to look at is people as a resource have location-based costs. And the location-based costs, they can be thought of as a series of stepped planes. And as the slope across the different location changes, things tend to move or gravitate in a direction. Now, this slide here, we did some research and tried to identify a particular type of vocation and what it costs to have a person, to employ a person to do that task in China, India, and the United States in 1994. And what's really interesting is what's happened in the pressure differential between the different locations. So there used to be a huge incentive to move jobs offshore. And there's still a strong incentive to move jobs offshore, but those incentives are, or that pressure differential is decreasing. And that leads to the viscosity issue, and there's the viscosity of transaction, a viscosity of proximity. How mobile are the jobs that move across? How easy it is or difficult is it to take something and move it somewhere else? There's also a viscosity of information flow and of other resources. Now, a long time ago, I guess it was 2003, we created this slide to focus on the fact that all of the efforts that you make to cut costs have limitations. They don't add value, they just streamline the system, creating products that people want, services that people want, making better things, increasing the bottom line. And what you can't necessarily read at the bottom, it says, design and engineering is where value goes into your product. And now a little bit of picture of what our industry looks like. And before we go further, what I want to do is I'm throwing lots of data points at you. There's many, many different ways of looking at things. And what we're trying to do is to give context of different ways of viewing things. There's a movie out recently, I don't know, I'm blanking on the name of it, where I think they showed lots of different points of view. And as you had different points of view, you got a more and fuller picture of the story. But what we're trying to do here is to give you many, many different ways to look at the problem. So our industry consists of the traditional big CAD, which became high-end CAD, which now we refer to as specialized MCAD. And then we also have the mainstream MCAD products. But there are many other, there's the AEC folks, the hardware, the processors. I mean, if you look at each one of these boxes contains a subset of our industry, and this is only a small piece of it. We have a very, very complex, robust, interrelated set of markets, and the relationships between these things are incredibly difficult to map. So why do we look at vectors? We look at vectors to highlight opportunities, to see if we can find underlying principles, to learn from markets. I mean, one of the things that you'll see here at COFES is that we have AEC folks, CAE folks, BIM, construction, all together dealing with different markets. The markets have different dynamics, and in some ways they're very, very familiar and very similar to one another, and in other very subtle ways, but clearly important, they're quite different. And understanding what can apply and how it applies going across is one of the things that we at Cyon Research focus a lot on. So design tools used to be really, really expensive when people were cheap, and that has transitioned. This is another way of looking at it. About 4 years ago, I was asked, well, what happened after 1998? Well, 4 things have happened. People have gotten more expensive. Tools have gotten better. Now less expensive people can start using the tools, and less expensive people in terms of not only the skill set, but also in terms of the location can start using the tools. The cost of systems has dropped in terms of the amount of time of salary. Till today, you can get a lot of stuff very, very cheap, inexpensive, and even free. And for those who are interested in taking notes, all of these slides will be available to you post-COFES on the website, and we'll go from there. Now, here's another vector. The vectors see, use, comment, interact, build on, and manufacture. And what we're doing here is getting a little diagram of what the different vertical markets deal with. GIS doesn't really, you don't really use GIS to build on or manufacture from so much as you use it to see, use, interact, and understand. So there's a little joke that goes along with this. What's the difference between mechanical engineers and civil engineers? I know many of you have heard this before, but mechanical engineers, mechatronics, and EDA is all used to build bombs, and GIS is used to find targets, and AEC, civil, and plant are used to build targets. It's just a different way of looking at how things are related. It's an old joke, but it's a different way of looking at it. We can look at how things are scaled and how the different markets relate to scales. We can look in terms of the numbers of elements that they deal with, or in terms of their geometric complexity. One of the things that I want to point out here is there are no numbers on most of these. You can argue about any of the specifics of any of them. What's important is the relationship between the various systems. So if we look here, one of the things that really stands out if we look at the vector of stakeholders is AEC. Architecture, engineering, and construction is very, very different than mechanical and EDA, primarily because there's a discontinuity between who is investing in the system and the beneficiaries of the system. And we'll get back to this later on. This is an owner's perspective of what a project looks like. And let's see if we can get this to work. The front-end loading, estimate the scope, design the project, procure it, build it, start it up, run it, maintain it, support it, improve it, and then figure out how to replace it and run this whole thing all over again. I was at Don Brown's CPDA event a couple of years ago, and thinking about what was being presented, and this idea came to me that there are other ways of looking at it. And if we cross the number of units that are made for a model of something and the design life of a model, and by design life I mean how long I'm actively engaged in the design process of something, you have a very interesting natural, this is a log-log scale, a natural line. We have biopharmaceutical processed foods, a fad like a pet rock, consumer electronics, consumer durables, automotive, space systems, air, infrastructure, AEC. Now if we take this and change it just a little bit and talk about how long the sales life of something is, what's happening is that there's this the slope changes, and I'll see if I can go back. The slope changes, and some things stand out. This is a simple bubble diagram. It's used to explore relationships and why are some things different. Numbers of users versus the complexity of the solution. Now, PLM, there are a lot of different ways of thinking about PLM, and this is one vector of words that goes through from create to maintain. Others have different ways of saying the same thing, and there are other relationships that are similar to it. Each of these can be considered as a vector for understanding what's going on. This is from a 1970 slide from Nolan and Nolan, and what's interesting, we talk about technology proficiency, individual learning and automation of tasks, automation of processes, and then automation between organizations. And we have engineering PDM kind of fits in here, enterprise PDM, and overall enterprise PLM, and maps out very, very well. You've all seen the standard life cycle committed costs versus funds spent. So we applied these different approaches to take a look at and try to understand the CAE marketplace, either last summer or the summer before that. And we were looking at the CAE marketplace in total. And the CAE marketplace has tremendous amount of very, very specific niches, all fitting neatly together with lots and lots of overlap, and there is no one thing that you can call the CAE marketplace. So we had to do some thinking about what's really happening within, who's competing with who in the marketplace. And we started by looking at the marketplace by saying, what types of problems am I dealing with? And we broke them down into these categories, which you've probably already read. Straightforward, and we use the example of a phone. If I drop it, will it break? Hard, if I take the cover off, is the tab going to break? If I drop it, will I get disconnected? That's a difficult problem. And so on. So we started out, there are big problems, difficult problems, automatable problems, and straightforward problems. And they all have to exist within the context of a simulation information management system, which is referred to by different companies with different terms. So we took this and we really said, there's the nature of the question, the number of degrees of freedom we have to deal with, and whether they're simple or complex. And so that broke down into straightforward problems, difficult problems, and hairy problems. And then we looked at integration, and again, got another picture of it. And so this mapped out into systems that are integral to a design system, systems that have integrated. There's a process flow, but it's not a simple, not straightforward in terms of the going back and forth. There's a stepwise connection. And then standalone systems to deal with straightforward, difficult, and hairy problems. Now, one of the things that I need to point out about this particular slide, first of all, it's too small to read. There's a white paper available for free on our website, which was sponsored by both Autodesk and SolidWorks. CyonResearch.com/whitepapers, and you can see the details on it. The second is any one of these tools can be used in any one of these boxes, but this is where their customers find themselves most often. And we place the same thing in terms of computational fluid dynamics. And it really gave us a much better understanding for who was doing what, and for a customer to come on board and say, you know, my problems fall more along the lines of an integrated process. I'm dealing with designers who need to have a good feel for something. Or I'm dealing with very, very difficult problems that I need standalone systems for that are dedicated to focusing on my technical issue or some combination thereof. There's also PIDO, and for those, particularly for those of you in the AEC side, PIDO is Process Integration and Design Optimization. And there is a number of automation and integration levels that are being dealt with. There's mesh-based templates, there are model-based templates, and there's abstract modeling, which we're going to talk a little bit about in one of the sessions on Friday and Saturday. So, market maps. Here is another market map, and I happen to like this thing because this talks a little bit about the process. We talked about the why, you would use something, and the what. So we create, we modify, we consume, and we deal with formats, toolkits, applications, and services, and we can throw things on here that fall within the different sections. But in doing this, as an exploration, we find that really formats are different than toolkits, applications, and services, and they're kind of something that we should fold off into a different direction so we have a more complex map. Now, we'll get back later on and we'll talk specifically about what happens in this particular segment here. Reach versus range is another issue. We're talking about product complexity versus process complexity. So, this is the beginning of what's referred to as the bubble map section. There are regions of personal productivity and regions of enterprise productivity, and we're going to come back to this later because those terms have evolved from what we've seen in the early 2000s to what's happening now. But if we map project complexity against geometric difficulty, you can see that GIS systems have very large, complex projects, lots and lots of elements, not a lot of geometric difficulty. Industrial design, very difficult surfaces, very, very difficult individual geometry, not necessarily particularly complex in terms of the project complexity. And then down here in the lower left-hand corner, we have things that are dedicated towards drafting or rather than design, or drawings rather than models. And we can go on and map markets on here. Architecture, engineering, and construction is somewhere around there in the green. Process and plant is more complex than architecture in general. Process-centric mechanical design, this is the traditional specialized MCAD. Shipbuilding and offshore is somewhere in between. And then this rest of this thing is where product-centric mechanical design has resided, which is the mainstream MCAD. And we can start to overlay products on here. Now, I will say that some of these names are older than others and probably could be updated. But the bottom line here is that, actually, let's go back here. Revit, when it first came out, filled this area of the map, and over time has evolved to fill the entire arena along with Bentley and Archicad. And so we see the CATIA and NX, and then the primary mid-range mainstream MCAD, and somewhere in this Netherland has been Pro-E Wildfire, and this is the picture that we drew in 2003. There's been a lot of shift. The mainstream MCAD systems are no longer constrained by what they can do, and the specialized MCAD systems have reached down and added ease of use and are no longer constrained to serving the needs of the esoteric. Also, the pricing has been pretty much in the same area. So what used to be spread out all the way throughout is no longer differentiated by either geometric difficulty or project complexity. So something's going on. There's another vector that we need to find that differentiates between what happens at the $20,000 a seat range and the $5,000, $6,000 a seat range. So what is that? Well, we explored that a little bit, and I think we'll get to an idea of what that is in a few slides. Through this investigation, we've been trying to understand what PLM is. And this is my personal definition of PLM versus not PLM. I'm not real fond of the term PLM but I'm trying to get a handle on a clear way to differentiate between what folks who call PLM is and what those who are not using the term are talking about. So PLM is a way to go from the top down, rethink what you're doing, with an opportunity for massive gains, and impose change on an organization in order to do what really needs to be done. The problem is, in order to achieve those changes, it's not cheap and it's not without risk. And the biggest risk with PLM as a rethink and change is the ability of your organization and the individuals within the organization to accept and move forward with the change. It's not a problem with the software. It's an issue about change and change management. Now, non-PLM solutions basically solve the same problem. They don't do it with the top-down vision. They're not optimized specifically for the enterprise. They don't have the potential for the massive gains that you would get for enforcing a top-down change. They also don't have the problem of forcing change on individuals and on organizations. And you can build change a little bit at a time and let time carry the organizations forward. Now, this is not a better or worse, it's a different. And if your organization is one that can manage the change and is built to accept it, then you may be more inclined to a PLM solution. If you're not, and you should know your internal political situation, then you might want to consider going a non-PLM solution. But it is something that you need to think about really carefully. So PLM, greater risk, greater cost in exchange for greater reward, potentially. So let's go back to the personal productivity and enterprise productivity. Really what's happening is these things have emerged, and you can look at non-PLM and flexible, aligned to the current practice, and PLM, opportunities to rethink, redesign, and impose constraints. So that's the PLM side. What's going on the BIM side? This is a picture similar of what's happening in the architecture construction marketplace. So we have the model, there's the create, collaborate, build, manage, and interoperate with. And then you have the architect and the architect's team, the engineer, the contractor. The contractor gives the stuff to the specialty contractor who deals with the supplier, and the owner is dealing with it. And some things work across. Some tools operate in multiple areas. Some boxes don't really apply. But there are a lot of tools that can map to this, and there's a lot of opportunity to make this work. But the key thing here is the owner is the one who is paying for it all. The owner is the one that reaps the benefit, but many of the things that are required to really get the leverage and the rethink are imposed upon folks at this end, and there's a change in a process problem. Another way to look at it is construction stack components. And unfortunately, this doesn't show up as well as it does on the monitor, but there's things here that are glowing that are the realm of the architect and the designer, but there are things that happen off-site, there are things that happen in the main office, there are things that happen in the design area, and if you try and map all of this stuff out, you get a better picture of the relationships of who's doing what. Now, in the general IT, there's the concept of IT technology stacks. So the yes here is yellow and the blue is no, but there's an Oracle stack, an SAP stack, a Microsoft stack, an IBM stack, and for those that are interested, there's an Open stack as well. And I looked at this and said that really today, what's happening in architecture is that there's an Autodesk stack, a Bentley stack, and an open stack, and sort of there's two Autodesk stacks. There's an Autodesk stack or an AutoCAD stack in architecture and a Revit stack in architecture. And the opportunities here are very, very interesting. And if we look at the same level of stack, now this was done a couple of years ago, but in construction, we've got construction design, steel design, precast, cast-in-place concrete fabrication, collaboration framework, etc. And it's a lot. We've talked before about viscosity. The viscosity is a lot lower when you're staying in one stack than when you have to move from stack to stack. And this gets back to the interoperability problem, which we don't want to deal with, but which we talk about incessantly. But the OpenStack, I think, and the agreement between Autodesk and Bentley recently has decreased the viscosity within the construction stack. So we talked about the differences between mainstream and specialized. We talked a little bit about the difference between PLM and non-PLM. We did another paper, also available at cyonresearch.com/whitepapers, that looked at the specialized and mainstream systems on the MCAD side. And the key thing that we found that differentiates the specialized MCAD vendors from the mainstream MCAD vendors is the fact that mainstream vendors have at their core the need and desire and focus on increasing the value they bring to their customers globally as a group. Whereas the specialized vendors have at their core to advance the technology as far and as fast as possible to serve the needs of their key clients. At the same time, they still need to advance the technology for all of their clients. So we talked about PLM, we talked about BIM. BIM is not PLM. If PLM is an opportunity to change the way we do things, so is BIM. But PLM is a system that focuses on a single data stream, and BIM deals with lots of single data streams, but it's focusing on a series or totality of data. And what's more important in BIM is the handoff that takes place between all of the participants. That's the key focus on building information modeling in my viewpoint. So that was the first 20 minutes, and now we're starting to talk about the surveys that we did. So round one we conducted with Merrill Lynch. This is the required statement saying that the work that we did is joint research, but our results and what we claim is ours and what they claim is theirs. So this white paper is actually in your packets, so you have access to it in the white bags. We looked at a number of different relationships that stood out at the data. So one of the things we looked at was, is there anything different between Revit and Bentley? And we found that here was the most important and least important. So Bentley ranked Bentley's customers, I have to say this carefully, Bentley's customers were more concerned about initial price and transition costs than Revit customers. Bentley's customers were more concerned about cost containment than Revit customers. Revit customers were much, much more interested in the opportunity to use the transition from non-Revit to Revit to change the way they do business than Bentley customers were. And Revit customers were more interested in things that they wrote in that we weren't asking. And in the second survey, which we'll get to, we started asking those questions. The other thing is architecture and engineering is different than construction. There are different drivers, there are different needs, and there are different criteria for decisions. So we looked at within AEC, how do the construction side versus the AE side view things. So AE, architects and engineers, were much more interested in the cost. They were more interested in the total cost of ownership, while contractors and construction folks were much more interested in implementing a design outsourcing model, and I say outsourcing as opposed to offshore, and they were much more keen on improving asset utilization. Now, I know this is an eye chart, but I wanted to give you an idea of the type of data analysis that we do. So we have the raw data here in terms of how your firm differentiates yourself against its competition. So we had a number of key components, and we looked at all the respondents. We looked at those who are likely to decrease their spending in the case of a downturn, and we looked at those who were likely to increase their spending in the case of a downturn. And we asked this before the crash. So some of the things that you can look in terms of color, the people who are more likely to increase spending in the case of a downturn were much more interested in customization. Now, this is the strength of the response. The difference here between quality overall, but the customization was an order of magnitude, more than 1 sigma away in how strongly they felt about customization versus their peers. We went back and made this a little bit easier to see. So in the green are the folks who are likely to invest in a downturn to improve their competitive position. So they're much more likely to turn their hardware over quicker or hold on to it longer. They are much more likely to be a C-level executive. They have better vision. They're much more likely to have a short procurement cycle. And they hop on to software relatively quickly in terms of their rev cycle. There's a lot of meat. There are 57 or 58 9 charts and tables in that report. There's a great deal of value in the existing report, particularly if you're looking to identify who might be a target customer in a difficult time. So we went back. Now it's 6-8 months later from when we collected the original data, and we made a new survey. And we asked a lot of questions that were enriched by what we got from the first survey. And this survey is currently in process. The first survey had 200 user respondents. As of this morning, this one had 477 user respondents, and we're looking to get close to 600 or 800 before we are done. So it's very good, very hard data. And this is a survey that takes about 25 or 30 minutes to complete. What we're doing to entice this activity is we're giving the report, which is on sale at a not insignificant price, away to those who actually complete it. So what have we seen in preliminary look at the data so far? Well, I just picked out one question to look at, and that is, what have you done or what are you about to do in terms of software acquisitions and maintenance so far? So we have seen the results of the software companies. We know what's going on. And so far, 25% of the respondents have held all new acquisitions. 19% have delayed acquisitions in progress. 14% have canceled acquisitions in progress. And 22% have discontinued software maintenance already for unused seats. 15% have done it selectively, and 8% have done it across the board. What's more interesting to me is the response of what they're saying that they are about to do. So the users were asked, what have you done already, and what are you about to do? 8% more are going to hold all new acquisitions. 7% are going to delay acquisitions in process, and another 5% are going to cancel. This is about a third as many as we've already seen is about to happen again. The same thing on discontinued seats. So that's scary. What's really of concern is what I refer to as overhang. Overhang is we're seriously considering doing, but we're not yet about to do it. So if the economy goes souther, yeah. I'm not sure how much souther there is, but if the economy continues to not recover, I guess is the better way, an additional 25% will hold all new acquisitions. An additional 19% will delay acquisitions in progress. An additional 14% will cancel acquisitions in progress. And here's the real one. Those are really big numbers. Now, there's some upsides. One is if the economy shows signs of life, maybe this stuff won't happen. The other thing is 15% have used this time to recoup and move forward without jumping an increase on the budget. 12% are considering doing it, and 12% are about to do it, and 27% are considering it. By the way, this slide was much prettier before it was deleted before the lecture. But the really impressive thing to me is that 10% are actually increasing spending, or have increased spending, in order to get a strategic advantage against the competition. 11% more are about to, and 35% are seriously considering it. Now, I think that those are very encouraging numbers. What it says to me is that if I am not in one of those numbers, I need to be really concerned about what my competition is going to be doing coming out of this recession. Anyway, that was just a look at what we've got. I hope I've entertained you, piqued some curiosity. The results of the full survey I hope to have out in the June timeframe. And if you have not participated in the survey, see me and I'll tell you how you can get into it. Thank you. Questions? The question was, why is there such increased participation? And if I can do this, I sent out an invitation to the COFES user community, the people who we invite to COFES. We had a very significant response rate on that. We sent out on Twitter, DLIP sent out to his group. We sent out information on, say, Chris Brown from PTC sent data out. We sent from a number of other vendors. We had asked them to send it out to their users. Dan Raker, his Connect Press, put his out. The other community, the bloggers, put it out. But what really made a difference was when, within 24 hours of it going out on Desktop Engineering, we had 350 responses. We actually have 600 responses so far, but only 477 are users. That's it? Yes, Peter.
So you have the evidence, because they always people who are dropping entity on the software to save money. How many of those are remaining fundamentally loyal to the maker and just hope?
So we actually have data on that. The answer is I can get the data, and I hope to have it to you in June, but it's deep inside. There's a lot of text commentary. For instance, when we asked them about, you're going to cut your budget, how much are you going to cut it by? And they told us, and the next question was, how are you going to do that? And so we have the specific responses, which we need to go back and categorize to get some conclusion on it. But the data is actually there. It's very, very rich. There's another point in here that unfortunately I can't show you. We asked the users what they expected to happen with their software expenditure, with their engineering department expenditure as a whole, and their corporate revenue on a half year by half year basis going forward for the next 4 years. So software IT, and I looked at the numbers this morning, software IT spend for engineering across the board doesn't go positive until Q2 next year. Excuse me, Q4 next year. So the expectation is they're not going to increase software spending from 2007 until at least the second half of 2010. Yes, Pete?
So the real question I was aiming at was, I understand spending's down. What I'm wondering is how much of it that is we'll stay with our vendor, we're preferring MA, and how much of it are actively migrating to lower cost.
And as I said, in the comments, it says, if we can negotiate a deal with our vendor, we're going to stick with them. If we can't, we're going to move. And what I don't have for you, I can show you the comment. What I can't tell you is what percentage of people have expressed that opinion. And that will take some deep work. Thank you.